Okay, so today's lesson is on linear inequalities. We are going to first learn how to read linear inequalities. So we have the first example, x is, and then this symbol right there is called greater than. So x is greater than -1. And that's how we pronounce it. To graph it, x is greater than -1. At -1, we're going to have an open circle. The x is not allowed to equal -1, but it's allowed to be just right up close to it as long as it is greater than 1. So anything greater than 1 works. So we have an open circle meaning not equal to, and then anything to the right. The next one says x is less than. This symbol is pronounced less than, in this case 4. Again, we have an open circle at 4, meaning we're not allowed to equal 4, and then anything less than it. The next one says x is, and then this symbol is pronounced less than or equal to, in this case 2, which means it's allowed to equal to and then anything less than it. The way we graph that is we put a closed circle at 2, and then anything less than it is to the left. Less than is to the left. It also kind of looks like an L. Do you see how if you kind of tilt it, it might look like an L? So L less than left. The next one says x is, and this symbol right here is greater than or equal to -3. So at -3, I have a closed circle, filled in circle, and x is greater than it, so greater than is to the right. So one way you can think about this is if you have like two numbers that you know are less than the other one. So let's say 3 is less than 4. If you think of this little thing as an alligator, and those are like little teeth, and you're thinking the alligator always wants to eat the bigger number. So you can think of it like as a little mouth. That's one way of thinking about it. You can think of less than kind of looks like an L and starts with L. Also, the arrows here. So the arrow on our graph matches the arrow. If you want to think about it as looking like an arrow, that will also work as long as the x is in the front. Which brings us to our next example where x is not in the front. So see how we have -3 is greater than x? -3 is greater than x. Well, that's hard to interpret. So what we can do is put the x in front and put the -3 in back. And remember I talked about the alligator. If this is an alligator and the alligator's teeth are eating the -3, well, if you rearrange the situation, the alligator still wants to eat the bigger thing, which in this case is -3. So if you change this around, now we can pronounce it x is less than -3, which is going to be very similar to the second one, x is less than 4. So we have -3. It's open because we're not allowed to be equal to it, and it's to the left because it's less than to the left. Or we can just follow the arrow. As long as the x is in front, this arrow, which it kind of looks like an arrow, should match this arrow. Okay? Our last example here is a compound inequality where we have multiple things going on here. The way we can pronounce this is 2 is less than x, which is less than or equal to 5. That is one way of writing it out or pronouncing it. Another way of pronouncing it would be x is, and if we're just talking about the first part, x has to be greater than, because the alligator is eating the x, right? So x is greater than 2, and we have to use that word and, x is less than or equal 2, 5. I don't really care which way you pronounce it. If you just want to pronounce it left to right, 2 is less than x, which is less than 5. Or you can say 2 is greater than, x is greater than 2, and x is also less than or equal to 5. So on our number line, we're going to have an open circle at 2 because we're not allowed to be equal to it, but we're going to have a closed circle at 5 because we are allowed to be equal to it. And x has to be both greater than 2 and less than 5, so it has to be the bar in between. So that's what a compound inequality looks like. Kind of reminds me of like a barbell, like at the gym, like something you would pump iron with. 2 dots on the end and a line in the middle, okay? Now we have some rules for multiplication of inequalities. Let's just say I was to take this inequality, 2 is less than 6, which we know is true. 2 truly is less than 6. If I multiply it by some number on the left and some number on the right, for example 3, 2 times 3 is 6 on the right side, 6 times 3 is 18. What happens to the inequality? Is 6 less than 18? Yeah, it is. In this case, we multiplied by a positive number and we kept the sign the same. All right, let's try something different. Let's multiply by, let's say, a negative 3. If I multiply by a negative 3, that gets me negative 6 on the left, and it gets me negative 18 on the right. In this case, please be careful. Which one is bigger? Which one would the alligator prefer? Well, the alligator would prefer to eat the negative 6 because negative 6 is bigger. And if you're thinking about on the number line, negative 6 is more to the right of negative 18 if you kept going out on one of these number lines. So if you multiply or divide it by negative here, when you multiply by negative, what happened? Your sign switched. Okay, so when we multiplied by a negative, the sign switched, and that was on something we know to be true. Negative 6 is greater than negative 18. Now, when we multiplied by a positive, what happened to our signs? Our signs kept the same. So we have a rule for that, and let me show you the mathematical way of writing that rule. It says if A is less than B and C is positive, then you can multiply C to both sides of the equation and keep them the same. A times C is less than B times C. Whereas if you have A is less than B and C is a negative, so you multiply by a negative, what happens to your sign? Your sign switches. So I know this algebraic writing is really difficult, so I'm going to just give it to you in words for the rule. If you multiply or divide by a negative, if you multiply or divide by a negative, you have to flip or reverse the inequality sign. So let me give you an example on that. So let's say you're solving this equation. Negative 2x is less than 8. So if I divide both sides by negative 2, my inequality is going to switch from a less than to a greater than. Positive 8 divided by negative 2, that's negative 4. My negative rules don't change. And this is now solved. Notice my inequality switched. And now I can graph that. X is greater than negative 4. So I have an open circle at negative 4, and greater than it is to the right. Now the only other time that you need to switch your inequalities is if you rearrange the inequalities. For example, 2 is less than x is really hard to read with the x in the back. So like we said earlier, if you move the x to the front and move the 2 to the back, the alligator still needs to eat whoever he was eating before. The alligator was eating the x before, it's still got to eat the x. Just because you've changed the order doesn't mean that the alligator changed his mind on what he wants to eat, right? So it should be x greater than 2. So those are the two times that you'd switch. So if I graph that, that's open circle at 2, and greater than is to the right. Okay, so the only two times you switch your sign is if you multiply or divide by negative, or if you rearrange the order. If you add to both sides or subtract to both sides, you're not going to be doing changing your inequality. Only if you multiply or divide by negative, or if you switch the whole left side and the right side of the equation around.